The Swiss Alpine forest stands so still it feels permanent. Stone pines older than any living memory, the cold smell of resin, a silence that seems carved into the rock itself. But something is missing, a sound, a presence, a season that should be here by now, and isn't. That absence the hook named, the season that should exist but doesn't, carries its own kind of cold. The Swiss Alps are warming roughly twice as fast as the global average. Think about what that means for a forest. The rest of the planet is warming, but these particular slopes, these specific trees, are warming at a pace the alpine ecosystem did not evolve to match. Nothing here did. And the first thing to break is snow. Not dramatically, not in a single catastrophic melt, but quietly. Season by season, the snowpack that these forests depend on is arriving later, thinning faster and releasing its water weeks ahead of schedule. For a Norway spruce that has spent thousands of years calibrating its growth cycle to a precise winter rhythm, roots dormant under insulating snow, soil moisture held in slow reserve, this is not a minor inconvenience. It is a mistiming of everything. The tree wakes up, in a sense, to a schedule that no longer matches the world around it. Walk upslope, and you begin to see what that mistiming produces over decades. The tree line, that boundary where forest gives way to open rock and thin air, is shifting. Stone pines and Norway spruce are pushing higher, chasing the temperatures they evolved for. But here is the thing about retreating upslope in the Alps. At a certain point, there is no more slope. There is only rock. The trees are climbing toward a ceiling they cannot break through. Into that stress, drought-weakened roots, shortened winters, trees pushed beyond their ecological comfort, enters a creature no larger than a sesame seed. The European spruce bark beetle, Ips typographs. Under normal conditions, cold winters function as a brake on its population, killing off larvae, slowing reproduction, keeping the beetle in a quiet, endemic balance with the forest. But warmer winters remove that brake. A tree under heat stress cannot produce enough resin to repel an attack. And when the attacks come in overwhelming numbers, the resin simply runs dry. Stand in one of the groves the beetle has moved through, and the world goes quiet in a particular way. The trunks are silver grey now, stripped of bark, the wood beneath them pale and dry. There is no canopy rustling, no bird song threading between branches, just columns of standing dead timber open to the sky, the silence where a forest used to breathe. But even here, in what looks like pure loss, the story refuses to be simple. Consider the Arola pine, the gnarled five-needle tree that clings to the highest forest zones in the Swiss Alps, and the spotted nutcracker, the bird that is its partner in one of the most ancient collaborations in this landscape. The nutcracker harvests the pine's seeds, caches thousands of them in the soil each autumn, and forgets enough of them that the tree regenerates across the mountain. The pine feeds the bird plants the tree. They have done this together for longer than any human record of this place exists. What is beginning to happen now, as warming shifts the timing of seed production and alters the nutcracker's migration and caching calendar, is that this ancient handshake is starting to slip. Not broken yet, but no longer perfectly synchronized. And in an ecosystem built on synchrony, a slip is where unraveling begins. The disruption does not stop at the trees. It moves through everything that depends on them. That ancient partnership between the Arola pine and the spotted nutcracker, two species locked in a rhythm older than any map of this place. Which do you think breaks the synchrony first? The tree's seed timing or the bird's migration calendar? Drop your answer in the comments below. because the answer matters more than you might expect. It changes everything downstream. The chamois has lived on these slopes for longer than any human settlement in the Alps. Sure-footed, cold-adapted, built for ice and steep rock, it has always known exactly where to be and when. But the alpine meadows it evolved to graze are drying out before the season ends now. The grass is gone before the summer is. So the chamois climbs. And pressing into the forest also means pressing into the territory of the lynx, into unfamiliar disease exposure, into ranges where the old rules of survival no longer apply. The ibex tells a slightly different version of the same story. Alpine ibex are altering their grazing habits in response to rising temperatures, seeking high elevations on hot summer days, and reducing their food intake during this time. A trade-off between staying cool and staying fed. And that trade-off, repeated season after season, leaves a mark. Body condition declines. Reproductive success quietly shifts. The population numbers in the Swiss National Park may look stable on paper, but the animals inside it are running a different, harder calculation than they were a generation ago. Then there is the lynx. And the lynx is where this thread gets genuinely strange. The lynx was hunted to local extinction in Switzerland and reintroduced in the 1970s, one of the more remarkable conservation recoveries in European wildlife history. Its return has been celebrated as proof that ecosystems can be mended. But the lynx's prey, chamois, roe deer, are the same animals now being pushed into unfamiliar ranges by warming temperatures. An apex predator's recovery is only as stable as the prey base beneath it. The lynx did not come back to a fixed forest. It came back to one already mid-shift. Now, cut from that sweep of movement, from corridors and elevations and predator-prey dynamics across entire mountain ranges, down to a single nest. One nest, in a hollow tree, in a section of Swiss forest, where insect-eating migratory birds have returned for decades. The nest is empty in a season when it should not be. The birds arrived on schedule, or close to it, but the insects they depend on to feed their young had already hatched and passed. The hatch runs earlier now. The birds, navigating from wintering grounds thousands of miles away, have no way to read a calendar that has been quietly rewritten in their absence. One empty nest is not a crisis, but nest counts across the Swiss forest are accumulating into a pattern, and patterns are what ecologists read when they want to know what is coming. And yet, the spotted nutcracker is still here, still moving through the Arola pines, still pressing seeds into the soil with a precision that seems almost deliberate. Whether the synchrony between that bird and that tree is slipping, as the previous section asked, is a question researchers are still genuinely working to answer. The nutcracker-pine relationship is old enough and complex enough that its full dynamics remain unmapped. That is not a failure of science. That is a measure of how much depth this forest still holds. If you are watching this, you are part of the collective attention that makes understanding possible. And understanding, in a system this intricate, is not separate from protection. It is the beginning of it. The forest is still here. Still full of relationships older than any record we have kept. The question is simply whether we choose to understand them before the window closes. Subscribe to follow what happens next. Glacier Retreat is already rewriting the water system, feeding everything in this forest.